Welcome. This video is going to look at determining formula units for an ionic compound when you have what's called a polyatomic ion. And generally your polyatomic ion is going to be an anion. So atoms of an element can gain or lose electrons to form an ion known as a monoatomic ion. And that's what we've been working with so far. Okay, so you just have one ion for the positive cation. You just have one atom in the ion for the anion. But you can have a group of atoms that gain or lose electrons as a group to form an ion, and then it's known as a polyatomic, more than one atom making up the ion. They usually form anions or negative ions. It still acts like a single ion with just one oxidation number, and many contain oxygen and are called oxyanions. So what changes when you have a polyatomic ion? Really not a lot. If a compound needs more than one of the polyatomic ion to balance the electrons lost and gained, then you use a parenthesis around the entire polyatomic ion along with the subscript to show there's more than one of those polyatomic ions. But you just treat that whole polyatomic ion group as one unit, which is why we use the parentheses. You never change the subscripts within the polyatomic ion because then it's not the same polyatomic ion. Just like you don't change the subscripts in H2O because then it's not water any longer. So let's look at a couple examples here. Sodium combines with sulfate. Now you should have a common ion chart, or you can easily locate one online. And we'd start out just the same way we did when we were working with monoatomic ions. I find sodium on my periodic table. I see it's in family 1. So sodium is going to give up one electron to become stable, and I'm going to show that with my box. Sulfate I have to go find on a common ion table, and I see it's this whole group, SO4, 5 atoms, and it's given with a -2 charge, meaning these 5 atoms still need to gain 2 electrons. So I do this just like I did when it was a monoatomic ion. I put the SO4 in the box, and I guess I could have centered that a little better, so let me clean that up for you. I put the SO4 in the box, and then I draw in 2 minus signs to show it needs 2 more electrons. So 1 Na is not going to be enough for the SO4, so I'm going to have to bring in a second Na to donate a second electron. So then this formula would be Na2SO4. Now, since I only had 1 sulfate needed for this, then there's no need for parentheses. So let's look at the second one, where this will be a little bit different. So using the same procedure that I did up above on number 1, I look at magnesium. It's in family 2. So magnesium has 2 electrons to give. I'll draw it like so. And then chlorate, you have to be careful because there's chlorite, there's perchlorate, but chlorate is ClO3 with just a minus or a -1. So my ClO3, it's all one thing, can only pick up 1 electron. So I can see that I'm going to have to bring in a second chlorate in order for magnesium and chlorate to bond together. So now I have MgClO3, and I can't just put a 2 here because then people aren't sure, do I mean 2 chlorates or do I mean 32 chlorates? So that's why I use the parentheses. I have 2 of these ClO3 groups, and that'd be the proper way to show magnesium chlorate. So here's a couple. I would encourage you to pause and go ahead and try these on your own, and then I will go ahead and go through my solutions as well. So I look up sodium. Family 1, it's going to pick up a +1 charge. I look up hydrogen carbonate. It's HCO3 with just a -1 charge. So when I draw these two, see if I can draw them a little better. Sodium has 1 electron to give. HCO3 only picks up 1 electron. So this would just be NaHCO3. And again, no need for any parentheses. Magnesium, family 2A, a +2. Chlorine, now if you went and looked on your polyatomic ion chart, you won't find chlorine because this is an element. This is just -1. So I have magnesium giving up 2. So this is just a binary compound or monoatomic ions. So don't forget that that's a possibility. You're going to have to decide if it's monoatomic or polyatomic. So this would just be MgCl2. So I have a few more for you. Again, I encourage you to pause and try it on your own. So magnesium plus 2. So there's magnesium with its 2 electrons to give. Hydroxide is OH with a -1 charge. So just one OH will not be enough to get both ions stable. So I bring in another OH, and this would result in MgOH2. Now this is one where people say, well, why can't I just write MgOH2, because it's not going to confuse people. But it's important to realize that this, written this way, it means Mg with 2 OH groups taking the electrons. But if I write it like this looks like it's Mg with an O and an H and an H. So the parentheses make a big difference. So Mg parentheses OH2. Ammonium nitrate I included because this is one of the few cases where my positive ion, my cation, is not a metal. It's actually a polyatomic ion group of nonmetals. So NH4 you'll find on a common ion chart with a +1 charge. Nitrate you'll find with an NO3 with a -1 charge. So NH4 with its 1 electron, NO3 with its -1 charge. Just need one of each, so when combined it'd be NH4, NO3. Couple more for you to try. I'll just give you a hint. Peroxide is a polyatomic ion, so make sure you consult your chart for that. So hydrogen is in family 1A. It's a +1 charge. Peroxide is a polyatomic ion, O2, with a -2 charge to it. So hydrogen has 1 electron to give. O2 needs 2 electrons. So I'm going to need 2 hydrogen with the 1 oxygen for H2O2. And then calcium will pick up a +2 charge. Phosphate is PO4, and this is a -3 charge. This is going to be one of those messy ones where I have calcium with 2 charges to give away. I have, oops, let me get my pen back. I have the whole PO4 group will pick up 3. So one of each is not enough. A second calcium only fixes half the problem. Another PO4 fixes one problem but creates another. So finally I see that Ca3 PO4 parentheses 2 would be my correct ratio. To finish up this screencast, I'm going to talk just briefly about naming ionic compounds. Naming is actually very easy, even though it looks like a lot of information here. The cation is still given first and the anion second, so you name from left to right on the periodic table. For the cation, you just use the element's name, sodium, magnesium, aluminum, whatever it was. For the anion, if it's monoatomic, you change the last syllable of the anion to IDE. And we've talked about this before, like chlorine becomes chloride or oxygen becomes oxide. And if it's a polyatomic ion, it's even easier. You just use the name of the ion as given on the chart. For a transition metal, you do need to include the Roman numerals after the metal's name to show the oxidation number used, like copper 1 or iron 3. The only time you don't have to use Roman numerals with a transition metal is silver, because silver always is a +1 oxidation number. So looking at a few examples here, Ki is easy. This is just binary or monoatomic ions combining. My cation is simply potassium. It's not a transition metal, so I don't need any Roman numerals. Iodine became the anion, so it becomes iodide. Second one, calcium, is going to keep its name. Again, it's not a transition metal, so I don't have to do anything else with that. ClO4 is a polyatomic ion, so I simply look the name up and I see it's something called perchlorate. Silver, as I mentioned, is always a +1, so even though it's a transition metal, there's no need to use the Roman numerals. NO3 is a polyatomic ion with the name of nitrate, so silver nitrate. Number 4, now I have copper with something called chromate, and so I need to know how many electrons did copper give up. Well, if I look up CrO4, if I find chromate on a chart, I see that chromate needs 2 electrons. So if chromate needs 2 electrons and I only have 1 copper and 1 chromate, then copper must have donated 2 electrons. So this would be named copper parentheses 2 chromate. So here's a few for you to try, and you may want to pause and give each of these an attempt, and then I will go ahead and start working through my solutions as well. So for number 1, it's just going to be sodium sulfate. Again, sodium is not a transition metal, so no need for Roman numerals. Number 2, magnesium is the metal or the cation, so not a transition metal. And then chlorate is the polyatomic ion that it's combining with. Number 3, I have sodium, and since sulfur is the anion, it becomes sulfide. And then for iron and oxygen, iron is a polyatomic ion. Iron is a transition metal. So if oxygen needs 2 and there's only 1 of each, then I should realize that iron must have donated 2, and I would write this as iron 2 oxide.